All right, mass spectra. When we talk about mass spectra, spectra as in the plural of spectrum, it is a record. A mass spectra is a record that displays the chemical substituents of substances. It displays the chemical substituents of substances by using their masses, representing using the masses to represent them. That is what a mass spectra is. What a mass spectrum is, and the plural is mass spectra. That is done by using mass spectrometers. So, mass spectrometers are used to measure the masses of elements. So the most common one, and the one that we'll be using here, is called the brain bridge mass spectrometer. The brain bridge mass spectrometer is going to be working with the quantity of allowing ions, beams of ions, beams of ions to move through a velocity selector. It's going to allow beams of ions to move through a velocity selector. In the velocity selector, there is a magnetic field B. This is the magnetic field intensity. And an electric field E in perpendicular direction. They are both perpendicular to each other. So at the moment, the beams, the moment they get to the point where the B is here and E is here, they come in a horizontal way, in a horizontal manner. We will be having the electric force at that point in time to be equal to the magnetic force. Magnetic force is always equal to QV times B, where Q is the magnitude of the charge, V is the velocity with which it is moving, and B is the magnitude of that what's it called? Of the field strength, the magnetic field strength. So, and the electric field is always equal to EQ, where E is the electric field intensity and Q is the charge. Electric force is equal to EQ. So the two forces, you can see this is F, this is also F. At that point in time, they will be equal to each other. F will be equal to F. Hence, QVB will be equal to EQ. We can see E is common to both sides. We can just divide both sides by Q. Q is common to both sides, rather. So Q cancels Q. Hence, I'm able to see that my velocity is equal to the electric field strength upon the magnetic field strength. That's not over. Once it leaves that place, it gets to a point where it's going to be moving in a semicircle, in a circular manner of a circular path with a radius r. The circular path will be having a radius r, and we all know that whenever a radius r is involved, there is going to be a centripetal force. Centripetal force is given as mv to the second power upon r, where r is the radius of the circular path. And in this point, there is another magnetic field B naught. So the velocity here is equal to, the magnetic force here is equal to QV, just like this, but the B is different from this B. This is another magnetic field intensity, magnetic field strength rather. So, okay. We are now going to be equating the force of centripetal to the force of magnet. So the magnetic force is equal to the centripetal force. mv to the second power upon r is equal to qv b naught. This was done, I think, by J.J. Thomson. He did works on this. And this is velocity. This is also velocity. So one velocity cancels the square. We're left with mv is equal to qb naught over r. So let's cross multiply. R comes here. Dividing both sides by q, then m over q v is equal to qb naught r over q. Q is eliminated. So dividing both sides by v again, v over v, v here. So m over q is equal to b naught r over v. This is called the mass to charge ratio. The mass to charge ratio is a very important quantity in atomic physics. or we call it the nuclear physics per se. So the mass to charge ratio, m over q or q over m is equal to the velocity over b naught times the radius of the circular path. So this is gotten and this is also gotten. Now remember what v is, right? V is equal to E over B. So M over Q is equal to B naught R over E over B. And that is equal to B naught RB over E. So the mass to charge ratio is equal to B naught BR over the electric field intensity, where this B naught is the magnitude of the magnetic field in the second point, and B is at the first point, the one that is perpendicular to this electric field, and R is the radius of the circular path. Thank you.